We are witnessing one of the largest breakthroughs in energy technology and probably science altogether, and you might not even know about it. The first big indication that there had been a breakthrough was in December of last year, so almost exactly a year ago, when a national lab in California made history by achieving the first fusion ignition reaction. And I'll explain in a second why that's so important. But things really got exciting in August of this year, so only a few months ago, when that same team of researchers was able to do it again. And this is super important in science because being able to do something once is impressive, but being able to do it a second time, it becomes more impressive. Okay, they did it 2 times, but can they do it again? Oh yeah, they can. So some really smart people did a thing 3 times in California. Why does this matter? It matters because practically since the dawn of when we could understand energy as a concept, people believed that something like nuclear fusion was impossible. There's no way that you could get a greater energy output than what you put in. But then in the last few decades, we figured out that fusion may be able to work. But now the problem wasn't, could we have a fusion reaction, but could it actually produce energy that could power civilizations? And that's what happened here. The experiment was actually able to output more energy than what was inputted, and that's a big deal. Even though it was a small amount of energy, it proved that something like this was possible, and now the challenge would be, can we scale this up to actually support electrical grids? That's pretty cool, but haven't we been using nuclear energy to power our grid today? Sort of. All around the world we have nuclear power plants like this, but this is a reaction known as fission, where what we just were able to do was something called fusion. What's the difference between fusion and fission? Great question, Upside Down Drew. Here's a really simple graphic that explains the difference between a fission reaction, so what we see in nuclear energy today, where we're splitting a larger atom into 2 or more smaller atoms, and the product of that is energy. But fusion is where we join 2 or more lighter atoms into a larger atom. And fusion is what we were just able to do efficiently and successfully. And this is really hard to do because it takes a lot of energy to make this happen. These atoms do not want to combine into a larger atom, but if we're able to do it, the release of that reaction is more energy or heat. But the first law of thermodynamics literally says that you cannot create nor destroy energy or mass. Don't worry, my physics friends, we are not breaking any laws here. And that's because we're not creating or destroying any energy or mass. It is the binding of those atoms, that reaction, that is producing something useful to us as heat. It's the same reaction that's happening on the sun and all the other stars in the galaxy. And so the fact that we've actually been able to harness that is why many people are saying